So in today's video, we'll be looking at what we call the indeterminate form. Remember, we said that the indeterminate form is in the form when we look at the limit. When we do a direct substitution, then we will get 0 over 0. So this is what we call the indeterminate form. So what does it mean? It means that, well, when we do the direct substitution and we get that the numerator is equal to 0 and the denominator is also equal to 0, then that means that, well, those two, right, the numerator and the denominator have a common factor, and therefore we have to simplify by rationalizing or simplifying, or by using the substitution method, right? So we will be looking at all these factors, looking at some examples of how to evaluate the limit of an indeterminate form, right? Okay, so let's jump into it. So let's say find the limit as x approaches 1, right? As x approaches 1 of x minus 1, all divided by x squared plus x minus 2. Right, go ahead and try this on your own, right? So here, if we do the direct substitution, then we will have 1 minus 1 divided by 1 squared is 1 plus 1 minus 2, right? So 1 minus 1, that is 0, all divided by 1 plus 1 is 2 minus 2, that's 0. Okay, so here you can see that we have the indeterminate form, right? It's an indeterminate form. So what does that mean? It means that the numerator and the denominator have something in common, right? So if you simplify, we'll say, well, the limit as x approaches 1 of x minus 1 divided by x minus 1 times x plus 2 in that case, right? That's x plus 2. So you can see that these two things here have something in common that makes this whole thing be an indeterminate form, right? So you can remove these two, right? If you factorize the bottom part, then you'll get that. Then you remove those two because they're common, and hence I'll have the limit as x approaches 1 of 1 over x plus 2. And then if I do the direct substitution, I will have 1 over 1 plus 2, which is the same as 1/3, which is approximately 0.0 or rather 0.33 recurring, right? So that is what we mean by the indeterminate form, and hence one should factorize and then cancel the common factors. Okay, let's look at more examples on this. Let's say we have the limit. Okay, this was 1. Okay, let's look at more examples. Okay, let's say we got the limit as x approaches 5, right? As x approaches 5 of x cubed minus 125, all divided by x minus 5, right? So here, let's do the direct substitution first. Well, 5 cubed minus 125, all divided by 5 minus 5, right? Do the direct substitution, then you will have 5 cubed is 125, 125 minus 125, that's 0, and then 5 minus 5, that is 0. So here we have an indeterminate form. We have what we call an indeterminate form. What does it mean? Well, it means that we have to factorize, right? So meaning we have the limit as x approaches 5 of x minus 5, right? All divided by x minus 5. So here you can see that, okay, here we have a common factor, right? Because we got this indeterminate form. Here on the numerator, there's nothing you can do, right? You cannot simplify this. So if you cannot simplify, that means we have to simplify the top part, which is the numerator. So if we have a common factor, that means what is here on the bottom is also what is there on top, right? And here at the bottom we have x minus 5. That means that on top we should have x minus 5, and hence why I wrote x minus 5. And then you can write the remaining part, which is you square this part here, square, and then you square this, and then you times these two. 5 times x is 5x, and then here you have the opposite, and then this is always positive. I'm using the SOAP method. So, and then here I can remove these two, right? If you don't know what's the SOP method, go back and watch my prior videos. You will know what's an SOP method. Basically, when you factorizing the difference between 2 cubes or sum of 3 cubes. Okay, so here I'll have the limit as x approaches 5 of x squared plus 5x, and then plus 5 squared is 25, right? So I can do the direct substitution. 5 squared plus 5x, right, and then plus 25. It should be 5. There you go. So this should be 5, and here I have 5 squared is 25 plus 5 times 5 is 25 plus 25. So this is 60, 10, 70, 75, right? And that's our final answer in that case. Okay, so if you go ahead and substitute, so if you go ahead and open up your calculator and you substitute a number that is very close to 5, let's say a number very close to 5 on this rational function here. A number close to 5 is 4.9, or rather 4.99, right? Then let's say division, right? We should get a number that is very close to 75, and if I say answer cubed, right, minus 125 all divided by the answer, right, minus 5, right, and then we get a value of 74.85, which is very close to very close to 75, right? And hence that is how you prove whether your limit is correct. You take a number that is very close to 5, right, from the left hand side or to the right, or from the left hand side or from the right hand side. Your answer should be close to 75, right? Okay, hope that makes sense. So now what I'm going to do is I'll do some more examples. We have three types of method that one could use to solve these indeterminate form. So the first one is of course the simplification, or rather the factorization. If you have to factor the common factor, right, you have to take out the common factor. The second one is basically the rationalizing method. You have to rationalize in that case, so that means you have to rationalize. And then the third one is basically the substitution method. So so basically you have to, for this one here, it's basically when you have a polynomial functions. That is, when by polynomial functions I mean it's any function that does not have a square root, right? It doesn't have a square root. So if it doesn't have a square root, that means that you have to take out, you have to factorize in that case. But if it has, if your rational function has a square root involved, that means that it's either you do the substitution method or you rationalize, right? You rationalize. So I'll show you how and when to rationalize, or to do or to use the substitution method. Let's look at some more examples. Okay, let us say you have let's say find the limit as x approaches 2 of the function x plus 2 minus 2, right? All divided by x minus 2. Now go ahead and try this on your own. So here you can see that you have a square root, so that means that we cannot factorize, right? So what's here on the bottom is basically on top, but you cannot factorize, right? You cannot factorize, so that means that you have to use the substitution method, or the substitution method, or the rationalizing method. So in this case you can use both. Let me show you why. So when I use the substitution method, I'm taking, let's start with the substitution method, right? Let's start with the substitution method. So when we are taking substitution method, then you're taking the square root, right? You're taking the square root, and then you want to say, well, the square root, rather, let the square root of x plus 2 be equal to any variable that you wish to put, let's say k. So you're gonna say, well, let the square root here be equal to any variables, right? It can be k, can be u, can be anything, can be m, right? And then what you're gonna do, will say, well, let me solve for x, right? How do you solve for x? Well, I'm gonna square both sides, therefore I'll have x. I'll have x plus 2 equal to k squared, and therefore x is equal to k squared minus 2. Okay, and then what I'm gonna do, we can substitute, right? Therefore I'll have the limit as x approaches 2. Therefore we said our k is equal to the square root of x plus 2. Therefore I'll have k minus 2 all divided by, well, x is k squared minus 2, therefore I have k squared minus 2, then this minus 2 here. Therefore if you solve, then you will have the limit as x approaches 2 of k minus 2 all divided by k squared minus 4. Now here comes the thing. So this doesn't make sense. You have the limit as x approaches 2, but we are looking at x, but here on our function we have k, right? On our function we have k, so meaning we have to have k here in this case. So if k, we're gonna let x equal to 2, although x is not equal to 2, x is approaching 2, right? But in this case we're gonna say, well, x is equal to 2, then I'm gonna take the 2, substitute it here into this function here. Therefore I have 2 plus 2, which is equal to k, which is equal to the square root of 4, because 2 plus 2 is equal to 4, and the square root of 4 is 2, right? Therefore in this case I can say, well, the limit as k approaches 2, because k in that case it will be 2, and therefore k minus 2 divided by k squared minus 4, right? And then if you do the direct substitution, you can see that we'll have 0 over 0, right? If you do the direct substitution, you'll have 0 over 0, which is an indeterminate form. That means that I have to simplify. That means it will be the limit as k approaches 2, k minus 2. Here we do not have any square root. That means that what's on top will also be here at the bottom. Therefore I'll have k minus 2, and then times k plus 2 in that case. Therefore I can remove these two because they are common, and hence I'll have the limit as k approaches 2 of 1 over x, or rather k, k plus 2. If you do that direct substitution, you should get 1 over 4, right? So that is how you do a substitution method, right? You basically let the square root equal to a variable, then you solve for x, and then in that case you solve for k, or rather that variable, and then you just substitute your numbers, right? So if you use the rationalizing technique, right, if you're using the rationalizing technique, and this was the substitution method, right? Now let us look at the rationalizing method, right? Let's look at the rationalizing method. Now the rationalizing method, I hope you guys know how to rationalize, right? So basically, by rationalizing, let's look at an example. Let's say I have the square root of 3, let's say 2 divided by 3, right? And then I say rationalize this number here. So by rationalizing, I mean that I want you to remove the square root here on top. How do I remove the square root? Well, I have to times this by what? By the square root of 3, and then whatever I do on top, I do at the bottom as well, which is the square root of 3, and hence I know the square root times the square root will cross cancel whenever I have the same numbers here. Just like, for instance, if I have the square root of x times the square root of x, if these bases are the same, that means that the square root will fall off, and then I'll have the value of x, right? In that case, I'll have the value of x. Yeah, similarly here, I have the 3, I have the bases the same, and therefore I'll take down the what do you call this? I'll take down the square root, and hence I'll have 2 times 3 all divided by 2 square root of 3, which is the same as 3 divided by square root of 3. That will mean that 2 square root of 3 divided by 3 is the same as 3 all divided by 3, right? I hope this makes sense. Okay, yeah, I hope this makes sense here. Now hold on, where's the 3 coming from? Oh no, this should be 3 rather than 2, right? This should be 3 because it was 2 root 3, and then we times both sides, so this should be 3, and hence 3 and 3 will move. This should be 2 right here, right? So this should be 2 and this should be 2, right? I hope that makes sense, right? So let us just jump into it, right? So we had the limit, right? We had the limit as x approaches 2 of the square root x plus 2, yes, and then minus 2, all divided by what was it again? It's x minus 2, right? So it's x minus 2. So in this case, I want to remove the square root, right? So what do I do? Well, whenever you have a situation like this, right, you have to, where you want to use the rationalizing method, you're gonna times this by you're gonna say, well, x plus 2 minus 2, and then whatever you do on top, you do at the bottom, x plus 2 and then 2. So you're taking this whole function as it is, right? And then what you do, you basically change the sign, right? So whenever you have a situation like that, you're taking this you're basically taking the function as is, and then what you do, you basically change the sign, right? I hope that makes sense, right? Then thereafter, you basically you foil, right? You foil, therefore that means x plus 2 minus 2 times the square root of x plus 2 all divided by x minus 2 times the square root of x plus 2, right? So in this case, I'm gonna foil, so that means I'll have the limit as x approaches 2. I'm gonna use the foil method, right? F standing for the first, so first times first, so that times that. Remember, the bases are the same, therefore the exponent will drop, therefore I'll have x plus 2, right? And then outside times outside, that means this part here times that one will give us, so negative 2 times 2 it will give us negative 4. Then the inside, that means the inside will be this times that, right? Remember I said that times that, then this times that will give us negative 2 square root x plus 2, and then basically the last, which is that times that, that times that, which is basically positive 2 x plus 2, right? And this is all divided by, here again I want to FOIL, therefore I'll have x, well this is x plus 2, then that times that is negative 4, that times that is plus 2x, then this times that is negative 2 root x plus 2. Okay, so yeah, this one is a lot, it's a lot to do, a lot of factorization. So here you can see that these two are like terms. This one is negative, this one is positive, that means these two will move, right? And here I have x plus 2 minus 4, that means 2 minus 4, that's negative 2, right? So it will be the limit as x approaches 2 of x minus 2, and then all divided by, in this case here at the bottom I do not have any like terms, right? But here I can factorize, right? I can factorize by using grouping, right? If you know how to group, so that means I can see that here I have this common here, these two common, so I'll assign those two in one bracket. So I have x square root of x plus 2, and then minus 2 square root of x plus 2, right? And I'll assign this in one bracket. I'm going to say plus, can put a plus or negative. So here if I say plus, I'll have 2x, just 2x here, and then minus 4. So if you were to put a negative, that means this one will be positive 4 minus 2x. Okay, so here it will be the limit as x approaches 2 of x minus 2. So here I can take out the common factor, which this one here is common, so that means that, well, I could have a common factor outside, x plus 2, then inside I have x, and then minus 2, right? Minus 2, and then plus, here I have a common factor of 2, right? 2 is my common factor, therefore I have 2 outside, therefore x minus 2, right? Here I can also see that, well, this one here again is common, in the equation, therefore I have the limit as x approaches 2 of the function x minus 2, all divided by, if I take out the common factor, to be x minus 2, then I'll be remained with the square root of x plus 2, and hence these two are common, therefore I can take these two common out, right? And hence I'll have the limit, as x approaches 2 of the function 1 over square root of x plus 2, and then plus 2, right? And then there I can do the direct substitution. It would be 1 over, if I substitute, it would be 2 plus 2, which is 4, square root of 4 is 2. If I have 2 plus 2, and then 2 plus 2, that's 1 over 4. So I can see that this one here is the same as that one there. But yeah, the rationalizing, it was a bit too complicated. So what I would advise is to make this simple. It's basically whenever you have a square root, right? Whenever you have a square root and what's inside, basically the x doesn't have any power, let's say it is x raised to the power 1, because if it was x raised to the power 2, then we'll be talking about something else. Then the substitution method wouldn't work, right? The substitution method wouldn't work unless if it was x squared in that case, right? Or it is x cubed, right? But if it is x squared minus something, or plus minus something 2 or 3, then the substitution method wouldn't work. That means that in that case you have to use the rationalizing method, right? Let's look at more examples. Let's say we have the limit as x, right? Okay, so as x approaches 8, right, as x approaches 8 of the cube root of x minus 2 all divided by x minus 8, right? Go ahead and try this on your own and see what answer you get. So in this case here, remember we said whenever the x should be raised to the power 1, right, and there shouldn't be any other it should be x raised to the power 1 in that case, right? So here I can use the substitution method. So that means that, well, I'll say, well, let's say let x, or rather let k be equal to the cube root of x. So let k be equal to the cube root of x, and therefore if I solve for x, therefore x in that case is equal to k raised to the power 3. Okay, so if I substitute, then I'll have the limit as x approaches 8 of remember cube root of x is equal to k, therefore k minus 2 divided by x is equal to k cubed, right? Therefore k cubed minus 8, and then again I have to solve for k, right? Remember k, or rather x is 8, therefore if I put 8 there, I'll have a value of k to be 2. That means that the limit as k approaches 2, the function k minus 2 all divided by k cubed minus 8. So in this case I'll have if I do the direct substitution, I'll have 0 divided by 0, which in this case is an indeterminate form. So that means that I have to simplify. Therefore the limit as k approaches 2 of k minus 2, whatever is on top is also here on the bottom. So I have k minus 2, and then I square that, k squared, square that, that's 4, or 2 squared, then it times these two, 2k, the opposite, and then this is always positive, and then I can take these two down. I will have the limit as k approaches 2 of 1 over k squared plus 2k plus 4. Do the direct substitution, then you will get 1 over 4 plus 4 plus 4, right? That is 4 plus 4 is 8 plus 4, that's 10, 12. I mean this should be 1 over 12. Okay, so I hope that makes sense. You should get 1 over 12 in this case here. Okay, let's move on. Let's look at some more examples. Let's say I have try this on your own. Let's say come on, what's going on? I'm sorry about that, I had some technical glitch, right? Okay, let's look at another example. Let's say you have the limit as x approaches let's say as x approaches 1, yes, as x approaches 1 of x minus 1 all divided by the square root of x squared minus, or rather plus 3, and then minus 2. So go ahead and try this on your own, right? So in this case here, I notice that I have, if I do the direct substitution, I'll have 0, because 1 minus 1, that's 0. And if I plug in 1 there, That's 1 squared plus 3, which is 4. Square root of 4 is 2. 2 minus 2, that's 0. And then here I have 0. Okay, so this is an indeterminate form. Well, that means that we have to solve, we have to simplify further. So in this case, I cannot let this thing here be equal to a variable, because it'll just take me, let me just show you what I'm talking about. So if you say, well, let's say the square root of x squared plus 3 equal to, let's say, k, right? So in this case, we will have to square both sides, right? And therefore we will have x squared plus 3, which is equal to k squared, and therefore x squared is equal to k squared minus 3, and x again is equal to k squared minus 3 square root. So you can see that here again we have another square root that we will have to work with again, right? So it will take you back and forth. You'll be getting a square root all the time. That means that the substitution method will not work in that case. Remember, I said that what's inside the square root, basically the x should be always raised to the power 1 in order for the substitution method to work, right? So if not, then we have to use the rationalizing technique in this case. So I'll have the limit as x approaches 1 of the function x minus 1, all divided by x squared plus 3, right, minus 2. Remember, we said that you take this function as is, right? So I'm going to say, well, this is x squared plus 3, then 2, whatever I do on top I do at the bottom, x squared plus 3, and then 2. I basically change the sign. If this was negative, now it becomes positive, and hence become positive. And then you basically you foil, say let x the limit as x approaches 1. In this case, I'll have x the square root of x squared plus 3 plus 2x minus the square root of x squared plus 3 minus 2. Okay, all divided by that times that the square root of 4. Then we'll have x squared plus 3, and that times that, this times that will give us negative 4. Then that times that will give us negative 2 square root of x squared plus 3. That times that will give us positive 2 square root of x squared plus 3, right? You can see that these two here are the same, and then we have positive negative, that means they'll drop, and hence I'll have the limit as x approaches 1 of the function. Here on top, you can see here I have to factorize using grouping again, right? You can see that these two here, this part here has is common with this one here, so that means that I'll assign them in one bracket again. If I have x the square root of x squared plus 3 minus the square root of x squared plus 3, so I'm assigning them in one bracket because they have these two things in common. Again, this one here has something in common with that one. Remember, whenever you're doing grouping, you assign the one with the common, right? The two with common, right? So here I'm gonna say plus, then this one is 2x, this one is negative 2, right? Here at the bottom on the denominator, I'll have x squared, and then 3 minus 4, that's negative 1 in that case, right? So let us take out the common factor here. Well, the common factor in this case is this square root part here. So I'm going to take out that common factor. That means I have the square root of x squared plus 3 times what is left is x and then here basically 1, so negative 1, and then plus, if I take out 2 as a common factor, 2 is common, therefore I'll have x minus 1, and then this is all divided by x squared minus 1. Okay, so this is x, the limit as x approaches 1 in that case. Okay, so let me just remove this part here. Okay, so this was a negative. Okay, so now I can do by grouping. I can see that, well, this here is common with that one there, so it's a common factor, therefore I'll say the limit as x approaches 1. If I take up that common factor, will be x minus 1. Then what is left is basically this part here, which is x squared plus 3 and then plus 2, all divided by, if you factorize the bottom part, will have x minus 1 and then x plus 1, right? Then these two is common, they are common, and hence I'll have the limit as x approaches 1 of the function square root x squared plus 3 and then plus 2, all divided by x plus 1. And then if I do the direct substitution, then I'll have, on top I'll have the 1, then 1 squared plus 3 is 4, square root of 4 is 2, 2 plus 2, that's 4, and then all divided by here at the bottom, 1 plus 1 is 2, and then 4 divided by 2, that's 2, right? So that will be my final answer in that case, right? Yep. Okay, so let us look at some more examples. Let's look at some more examples. Remember, guys, if you want to be if you want to be perfect at this, you have to do examples after examples after examples, so that you can get the concept, right? Remember, I said this this topic here is the easiest topic out of them all. They'll be asking the same thing over and over and over again, right? So make sure that you do more examples. So here I have the limit as x. Let's try a bit more harder. Let's say h approaches 0 of the function 1 over let's say x plus h squared minus 1 over x squared, all divided by h, right? Let's try this one. Pause the video and try this on your own, right? So basically, do the direct substitution. If I put in h here, well, h is approaches 0, so if I put in that case, what am I doing? Okay, so this is all squared, right? Okay, so if I put in a h, if my h approaches 0, if I put in 0 there, well, I have this one removed, right? Therefore I have x squared, then 1 over x squared minus 1 over x squared, that's 0, right? And then this is basically 0, therefore I have an indeterminate form. That means that I have to factorize, right? So if we add, rather we simplify the top part first, we'll have the limit as h approaches 0, and then there I'll have x squared minus x plus h squared, all divided by x squared times x plus h squared, all divided by h. So I basically added the top part first, right? I added the top part first. So the next thing is to simplify further. Let's say, well, the limit as h approaches 0 of the function x squared minus x plus h squared, all divided by h x squared times x plus h squared, right? So basically I took this on top. Whenever I want to take this on top, but I'm going to times this by 1 over h. Whatever I do on the bottom, I'll do on top as well. Well, these two will cross cancel, and hence the h will be here on the bottom, right? The h will be here on the bottom, right? And hence it is here, right? I hope that you can see that the h there. Therefore, what I can do now, I'll say the limit as h approaches 0, right? And then if I put rather open this bracket up, if I have x squared minus x squared plus 2xh, and then plus h squared, all divided by h x squared times x squared plus 2xh minus or plus h squared, right? So do not make the mistake of cross cancelling these two, right? Do not make that mistake. Why? Because you cannot cross cancel, because we have a negative there, right? If it was a multiplication, then we could cross cancel them, but in this case it's a negative, so you cannot cross cancel. Therefore I can just solve further. Therefore the limit as h approaches 0, then I have x squared minus x squared. Well, these two will move, right? And therefore I have negative 2 xh minus h squared, all divided by, if I multiply this inside, I'll have negative h, not negative, hx raised to the power 4 plus 2x cubed h squared, and then plus h cubed x squared. Okay, now if you do the direct substitution in this case, meaning h is, let's say h is equal to 0, if h is equal to 0, that will move, right? Okay, so at the bottom we'll still have 0, so we cannot do the direct substitution. That means I have to simplify further. So by simplifying further, I can see that, well, all these terms have h in common, right? All these terms have h in common. So that means that I can take out h as a common factor on top. If I have the limit as h approaches 0, take out h as a common factor, therefore I have h negative 2x minus h, all divided by h times x raised to the power 4 plus 2x cubed h squared, and then plus h squared x squared. Okay, so yeah, you can see that these two here will move, right? And hence I'll have the limit as h approaches 0 of negative 2x minus h, all divided by x raised to the power 4 plus 2x cubed h squared, and then plus h squared x squared. Now I can do the direct substitution. Well, if you put in 0 there, you'll have negative 2x, and then here at the bottom this will move, that will move, and hence I'll have x raised to the power 4, right? So in this case I can simplify further, therefore I'll have 2 divided by x raised to the power 3, right? I hope that makes sense. And yeah, we'll end this video here. I hope that you try more examples when it comes to limit, because trust me, this is the easiest topic there is on calculus, right? You cannot get this topic wrong. And yeah, we'll do more examples on the limit. I'll look at more past papers, and yeah, I'll catch you on another one.